So what if they said differentiate sine of x squared minus 4? Would you know how to do that at this point? Find the instantaneous rate of change. I don't think, would you know how to do that? We will in a few minutes, okay? So you can guess, you can't distribute the sine through, you can't say it's sine of x squared minus sine of 4 or something, or 4 sine, because you can't separate those things. So this is kind of like you have an inside function, sine, or an outside function, u, okay? You have a, well, the inside function would be u, and the outside function would be sine of u. Okay, so you're gonna, what you do when you do the chain rule, you take the derivative of this, d du of this times d, the derivative of that with respect to x. And what you end up getting is, I'm going to write down a more formal definition, but what you end up getting, dy dx, in this case, would be equal to the derivative of sine of u times the derivative of this thing, which is like the inside function. Okay? So I'll talk about that. We'll show you how to do that in a minute. So let's say, for instance, we'll start with a simpler one. Okay? Like they do in the book. Rana. See, I'm writing the book. The book one's right here, so you don't even have to look in the book. 8x minus 12. 8x minus 12. So you know how to take the derivative of that. What's y prime equal to? 8. Okay? Now you're going to say, why the heck would you want to do this? I'll show you why the heck. You could differentiate things like the previous problem. Okay, so say I factor out a 4, and I have another inside. I can do that. I can rewrite this as 2x minus 3. Right? Couldn't I do that? This is equal to this. Yes. Now, if I let u equal 2x minus 3, okay, then I can rewrite this as y equals 4u. Right? Y equals 4u. Okay? And then I can take dy du. What's dy du? What's the derivative of this function with respect to u? 4, right? The u is the variable. What's du dx over here? 2, right? 2, right? What do I get if I multiply 2 times 4 together? 8. Okay? So, the what? Well, sometimes you have to, no, for this one, no, you wouldn't want to do that, okay? For this one, no, you wouldn't want to do it. It's just to illustrate a point, okay? So, what the chain rule says, if okay, it says dy dx is equal to, okay, dy du times du dx. Do you kind of see like there's some algebra here? What would cancel out here? Du's. See that? So I get dy dx equals, so what this says is I take the derivative, it's the derivative of the outside, derivative of outside function, if you have a composite function, derivative of outside times the derivative of the inside. So, so let me write down a formal definition. Can I do that? What they do in the book. The chain rule. I gotta pick a different color. Let's write it. Let's do a new page. Okay. Chain rule says if the chain rule if f is differentiable, can I just write diff? I'll write differentiable. At the point u equals g of x, and g is differentiable. It's a long word to write. Differentiable at x, then the composite function f of g of x, you know this notation, f of g of x, it means g is the inside function and f is the outside function. Remember that from you're done?
Yeah.
That goes into makeup. Okay, thank you. F of g of x, then f of g prime of x is equal to f prime of g of x. This looks too many g's and f's and w's and f times g prime of x. Okay? And I just kind of wrote the other definition. That's so confusing. Okay? So, example. Let's go back to that original problem. What did I have? Sine of x squared minus 4. Sine of x squared minus 4. Okay? So this is like f, and the whole outside function is g is equal to sine of u, where this thing is u. So what you do is you let x, you don't have to go through this each time either. You'll get it really quick. Let x squared minus 4 equal u. Okay? And so what I want to do, so sine of x squared minus 4, g equals sine of u. Okay? Because u equals x squared minus 4, and f is the inside function. So dy dx is going to be du of sine of u times dx of x squared minus 4. Good, perfect. dy dx. So the derivative with respect to x is equal to the derivative of the outside function times the derivative of the inside function. What's the derivative of sine of u? Cosine of u. What's the derivative of x squared minus 4? 2x. That's almost your derivative, because what I have to do now is, what did I let u equal to? X squared minus 4. So I have to take that x squared minus 4 and plug it back in. You see? Okay? Because you can't have u's and x's, okay? You just have to take, you want an answer with just x's in it. So what I end up with is cosine of x squared minus 4 times 2x. And sometimes they write that, to avoid confusion, because it's not cosine of this whole quantity, it's cosine of this quantity times 2x, they bring the 2x out in front, and they go cosine of x squared minus 4, like that. So basically what I did with a lot of complicated u's and du's and dx's, I took this thing left alone, the derivative of this thing left alone. So it's like cosine of x squared minus 4 times the derivative of x squared minus 4. You get that? Okay, so I'm not just going to say, okay, we're done, because we got to do a couple more examples. So
just leave it like that at the bottom?
Yes, just leave it just like that. Okay? Factor? Yeah, like that. No, that's fine. That's fine. You don't have to simplify or anything. Because you can't really distribute this. The 2x doesn't distribute through.
So how much easier is this than just using the product rule?
Well, you couldn't use the product rule on this, right? There's no way to take the derivative of that.
Oh, it's signed there.
Yeah,
Oh, okay.
there's no way to take the derivative of that.
Oh, yeah.
Okay?
Yeah.
So like one that you might want to try to do the product rule, watch
Because
out.
sine of x times.
Yeah, so let's just watch, okay? So say I have to find d dx of 3x squared plus 1 raised to the second power, okay? Okay, Kyle? So what I could do here, if I wanted to, is square out this whole thing, right? If I squared out this whole thing, I'd get 9x to the 4th plus 3x squared. No, plus 6x squared, sorry. Plus 6x squared plus 1, right? d dx of that. The other way I could do it is call this thing u, okay? So it's like 2 times u raised to the what power? 1 power, because that's the derivative. So that's the outside function. What's the derivative of the inside function? 6x, okay? And since I let u, in my head, I let u be 3x squared plus 2, I plug back in 3x squared plus 2. So you, plus 1. You don't have to do a u substitution every time. You know what I mean? You don't have to write down let u be this, but that you're kind of thinking about that in your head. Times, because that's the derivative of the inside function. So then you have to go like that, okay? And then I would multiply this times this, which gives you 12x times 3x squared plus 1, right? If I did want to distribute that, I get the same as the derivative over here, which is 36x to the 3 plus 12x, right? Which is what this would be if I multiplied it out.
So how do you know that to multiply by 6?
Because you always have to multiply, it's the derivative of the outside function, where you leave this part alone, times the derivative of the inside. The derivative of the inside is 6x. So there's like an outer function and an inner function. Okay? Yes, ma'am. This 2, because if I let u equal 3x squared plus 1, right? Then I have u squared, and the derivative of u squared is 2u. Okay? So I kind of skipped a little step there, okay? Because this is u, right? So it's the derivative of that outside function, which is u squared, times the derivative of the inside function, which is 6x. But I have to remember what was u? Oh yeah, u is 3x squared plus 1. But what happens is you get good at doing this without saying what's u, you know. I mean, you have to think in your head what's u, but you don't always have to write it down, because then, you know, it becomes more work. So, for instance, say I had, oh, we already did that one. Let's do another one. Oh, that's 2. let's just do a one that's different. So, so say for instance I have something like, okay, 3x to the 4th minus square root of x raised to the 5th power. Okay? What I don't want to do is I do not want to multiply 3x to the 4th minus root of x 5 times, right? Because that would be super, super messy, yes? And you'd probably make lots of mistakes. So what I do, so y equals this. So what should I let u be? 3x to the 4th minus root of x. Okay, I'm going to call it x to the 1/2 power. Because I want to take the derivative. Okay? And so now I can rewrite this as y equals u to the 5th. What's the derivative of y to the 5th? dy du is equal to 5u to the 4th, right? What's du dx? You can do this. What's the derivative of this with respect to x? 12x cubed, what?
Minus 1/2 x.
Minus 1/2 x to the negative 1/2, okay? Which is the same as bringing it down and making the square root. So dy dx, right? dy dx is equal to dy du, 5u to the 4th times this thing, which I'm going to write as 12x cubed minus 1 over 2 root of x. Okay? And I'm not quite done because I let u be something. What did I let u be? What's u? 3x to the 4th. So u is 5 times 3x, what I have in front, 3x to the 4th minus another way to write x to the 1/2. Root of x times that messy stuff over there. 12x cubed minus 1 over 2 root of x. So I do not think you would want to multiply this all out and then take the derivatives of all that and then simplify. Yes, sir?
With the second term, like after the 5, would that be?
Yeah, would not be to the fourth
to
root.
the 4th still.
Oh, sorry. You're right. That would be to the
That's not
4th.
right.
I'm sorry. Okay, there should be a 4th. Okay, thank you.
So we'd be fine with that answer.
This is, yeah, you don't have to simplify that answer.
Yeah,
No,
that's-
no. Okay, it's just showing that you know the chain rule. All right. So it's a, and furthermore, once you get good at this, you don't have to say, I could just do this in my head. Oh, it's 5 times this raised to the 4th, right? Times the derivative of the inside. Okay. Now, unfortunately, it gets more
Yeah, why do you
complicated.
even have to just do u? Why can't you just do that?
Yeah, you can, but I'm just trying to show you, to help you think about it, okay? Unfortunately, it gets a little more complicated, like sometimes you have more than one thing going on. So say now that I had the tangent, so g of t equals, tangent of 5 minus sine of 2t. Sine of 2t. So now what you have to do, you kind of have to use the chain rule within the chain rule. Okay, 2t. That's a t, sorry. T. Okay? So let me just do it without using any of the use stuff and see if you guys could follow it. Okay? What's the derivative of tangent? Secant squared. Okay? So, I got that one wrong on the test. Okay. So it's g prime of t is equal to secant squared of this thing, right? 5 minus sine of 2t. Now I have to take the derivative of this function, right? The inside function. What's the derivative of 5? 0. What's the derivative of sine of 2t? So there's going to be a negative cosine of 2t, but I also have to take the derivative, but negative, right? I also have to take the derivative of that 2t. What's the derivative of 2t? 2. So you have to apply the chain rule twice. Do you understand that? Okay? Because the outermost function is tangent. Then the next inner function is this thing, right? And the next inner function is 2t. So you have to take the derivative of the outside, then the derivative of the next, then the derivative of the next. And then you would simplify that a little bit. What I would do,
Where did you get that too?
derivative, you have to take the derivative of, so really what I'm finding is dg dt. So if I'm taking the derivative with respect to t, I have to take the derivative of any inside function over there. You see?
Where did you get that from?
Where did I get what?
The final two over there.
These two things?
I get where you got negative cosine of 2t.
Because then I have to apply the chain rule on this. Because I know how to take the derivative of cosine, the derivative of sine, but I also have to take the derivative of 2t, which is 2. You have to use the chain rule twice. So there's a chain rule within the chain rule.
Would that be easier to understand if you did the u on this one, or what? I don't know.
I think I might get confused because then I'd have to use u's and v's or something.
Is that the last?
No, it's not the class example. Okay?
So is that how you leave the answer?
Is that how you leave the answer? I would bring this stuff in front. Okay, so I would rewrite it as minus 2 cosine 2t times secant squared of 5 minus sine of 2t. And the only reason, I did that, okay, is because it could be confused. You want secant squared of this whole quantity, right? This is being multiplied by this, so it's secant squared of this, right, times this. You know what I'm saying? So you want to bring this out in front to indicate that you're not taking the secant squared of that number. Yes, ma'am.
So could you do the chain rule for sine of 2t and then repeat it there, plug that back in?
Yes. Yeah, you could do that.
Okay.
Okay? But you'll get lots and lots of practice with this. Okay? But this is one of the most stress things in calc. Okay? So here, let's do this one. This one. See if you could do this one. Let's try. You try. I have you tries in my algebra 1 class. Okay? Find dy dx, okay, if y equals sine of 5x. Sine of 5, so how do you say that? Sine of x to the 5th power. Okay? See if you could do that. See what you come up with. You try. Find dy dx. So again, this is the same as sine of x to the 5th power, right? That's equal to that. So now take the derivative of that. Oh, I can hit pause. The 4th cosine x, right? So it's because the derivative of the outside is 5, that's a 5, not a s, sorry. 5 sine of x raised to the 4th power, okay, times cosine x, right? Yeah, so it's like x to the 5th times the derivative of, cosine. So not that bad.
So where are you getting cosine x from? You're saying
So you have to take the derivative of the inside function.
So the outside function is sine 5th x, and the inside function is sine x.
The outside function is like u to the 5th, okay? Because so the sine of x is a function in itself, right? And so the inside function, u is u to the fifth, okay?
And then the inside function is sine of x.
Right, so
Sine x.
u equals sine of x. Okay, so what if they ask you to find the slope? Find the slope at x equals pi over 3. And by the way, on the next test, I'm taking down that unit circle. You gotta memorize it. Yes.
No.
Calc AB that isn't allowed to use unit circle.
We're not
okay?
Calc AB.
Yeah. You are not allowed. You will be expected to know the unit circle when you take a AB test. So you better learn it. Okay. Slope at x equals pi over 3. So what you want to do, it's 5 times the sine of pi over 3 raised to the 4th power times the cosine of pi over 3. Who remembers what the sine of pi over 3 is? Pi over 3 sine of
Square over 2.
root of 3 over 2 to the 4th, right? And this is 1/2. Okay, so if I simplify that, root of 3 times root of 3 times root of 3 times root of 3 is the same as 3 times 3, which is 9. 9? Yes. So that's equal to 5 times 9 over 2 to the 4th. What's 2 to the 4th? Oh, 16 times 1/2, which is equal to 45/32. What does that tell you? That tells you that if I graph this function, which is some funky looking function, at the point where x equals pi over 3, the slope of that curve would be 45/32. Huh? What? We're not done yet. Sorry. We have parametrics. Do you remember parametrics? Okay. Parametric derivatives. This won't take long, I promise. Parametric derivs. Okay? So, if you remember a parametric equation, it's an equation in which you have x's and y's doing two different things. So you have a point derivatives. You have a point x of t, okay, comma, y of t, and then you have something called parameters, where t is between two values. Do you remember doing this? Okay. X, if you took pre-calc advanced, you have you did parametric equations where x is doing something, so maybe like y equals x, or x equals 3t squared, and y equals 2t or something, and they're working in conjunction, and you made a table that might graph something like that. Remember, you could go into parametric mode in your calculators. If you don't remember that, you could come in and get, so this would graph, so you have to plot some points for t. So when t equals -1, you get out some value, and t equals -1 over here, you get a y value. So you have a t value, then you have an x value. You have a t value, then you'd have an x, and then you'd have a y, and then you plot those 2 points. Okay? And parametric equations are good for describing motion. Okay? With parametric derivatives, okay, the formula that you use is dy dx, okay, is equal to, they go through a derivation of it in the book, is equal to dy over dt over dx over dt. Okay? So for parametrics, and all three functions need to be differentiable. Okay, so dy dx, dy dt, and dx dt need to be differentiable at that point, meaning you can take the derivative of it. Okay? How do you tell if it's differentiable? By looking at the equation. Okay? So, say for instance you have, so here we go. Find sorry, find the tangent, and in the book they have tangent to the right hand branch. This is right hand branch of the parabola defined by parametrically, Parametrically, okay, by x equals secant t and y equals tangent t, and t, so you have to have a parameter too. T goes between pi over 2 and negative pi over 2 at the point root of 2 comma 1 where t equals pi over 4. Oh my god. T equals pi over 4. You say, what the heck? Okay, so let me kind of draw a picture of what they're talking about, okay? If you were to graph this thing parametrically, you put it into parametric equations, you would get a hyperbola, a right-hand part of a hyperbola, okay? So you would get something, if you were doing a graph, it would just be, I think, in this quadrant. No, it would be in the, you would get a right-hand part of a hyperbola, something that looks like this, okay? Kyle, you should pay attention, okay? So all you have to do here is you want to find the tangent line. There's a point on here, root of 2 comma 1, okay? You want to find the tangent line at that point, okay? The way you do that is you go dy dt over dx dt. What's dy dt? What's the derivative of this? What's the derivative of secant? Come on, what's the derivative of secant? Secant tangent, right? So it's secant t tangent t, okay, over what's dx dt? What's the derivative of tangent? Secant squared t, okay? Now this point, root of 2, 1, they got from plugging in pi over 4 in here and from plugging pi over 4 in there. Okay, that's where that point came from. So I might not give you that point, right? I might say at the point where t equals pi over 4, find the equation of the tangent line. Okay, so you would have to take pi over 4, plug it into here, take pi over 4, plug it into this. What's wrong? Yes?
Shouldn't that be switched?
Yes, it should be. Sorry. I'm sorry. X dy, yeah, I was looking at x instead of y. I'm almost, okay, sorry, quick. Thank you, Kayla, for paying attention, okay? dy dt is secant squared, sorry. Secant squared t. dx dt is secant t, sorry, secant t tangent t. Now, luckily this thing simplifies, okay? This is equal to, let's rewrite it with sines and cosines. Well, I could just cancel out one of these, right? So I get a secant t on the top, so that's equal to secant t over tangent t. How could I rewrite secant t? 1 over cosine t. How could I rewrite tangent t? Sine of t over cosine t. If I flip and multiply this, okay, I get 1 over sine of t, which is the same as cosecant t. So that is the derivative. Now, at pi over 4, I'm almost done, okay? At pi over 4, what is this equal to? That's a slope. Okay? 1 over square root of 2 over 2, which is the same as 2 over root of 2, right? Yes? I'm going to rationalize the denominator. I'm going to multiply by root of 2 over root of 2, which gives me 2 root of 2, 2 root of 2 over 2. Remember that? Which is equal to root of 2. That's the slope. Whoa. And the point is here. So I'm going to plug into y minus y1 equals the slope, root of 2 times x minus x1. Okay? Y minus y1 equals the slope, x minus x1, x1, y1. Okay? And that is equal to y equals root of 2 x. If I put it into slope intercept form, if I wanted to, which I don't want to, that becomes 2 plus 1. So altogether you'd have y equals root of 2 times x minus 1. Whoa. Okay, but that's okay. This is just fine right here. Okay? This is just fine right there. So that's pretty ugly stuff, right? But it's kind of fun. But okay, your homework is now on my website. Let me just flip it up here for you, because it's you get a look. You get a look. Sorry. Index. I hope it's there, because I posted it last night.
So we didn't really use the chain rule in our last example, did we?
We didn't use the chain other than the chain rule is the derivation for where that comes from, okay, which I didn't want to go into, okay. So Calc BC, if you want to write, I think I have to hit refresh, okay. Refresh, where's refresh, quick, there it is, chapter 4, I just put that up last night. So that's it, all I have is the first day, chain rule, it's on my website, you can look at.
So that we have to do that for Friday?
Yeah, homework for Friday. And so the chain rule takes lots of practice because it's confusing. So make sure you're doing this homework, okay?